And dear students, today we are going to discuss Hybridoma Technology, and this particular title is from the paper 102C, Unit 1. So, the topic of discussion will be Hybridoma Technology. This is the method of producing hybrid cells, and basically, what happened? Two different kind of cells are fused together. One is normal cell, and second one is cancerous cell. So once these cells are fused together, then it is known as hybridoma, or you can say hybrid cells. And what is the goal of this hybrid cell? It produces monoclonal antibody. So during the entire discussion, you will be able to know how this hybrid cells are produced, how monoclonal antibody is produced, and what are the different uses. So let's begin. So uh, let's know how the technology was come into the existence. So what happened in 1975? Two scientists, G. Kohler and Cesar Milstein, developed for the first time this technology. And this technology was a very big milestone in the field of biochemistry, and that is why they shared Nobel Prize in 1984 in medicine and physiology. So, goal of the technology, that means what is the purpose of this technology? So, what happened? This technology is mainly for production of monoclonal antibody, and the process start by injecting a mouse with the antigen that provoke an immune response. So, what happened when an antigen is introduced into the mice body start producing antibody, and that antibody is a kind of monoclonal antibody. So here in this diagram, you can see how mice is immunized, and then after some times, I mean through the several steps, these monoclonal antibodies are produced. So here, let's see the entire principle of this technology. So what happened? First, the mouse is injected with the antigens, and after some times, spleen cells are taken out from this mice. And spleen cells, what I mean to say, like the B cell, only the B cells are derived from the spleen cell, and then it was fused with the myeloma cells. So here myeloma cells is cancerous cells. So once these two different cells are fused together, then hybridoma cells are formed, and this hybridoma represent properties of both spleen cell as well as myeloma cells. So the next step is heart media selection. So what happened during fusion? Only few percentage of cells are undergo fusion. Remaining unfused cells need to be removed. Therefore, we need to pass through the heart medium. So after passing through the heart's medium, this is going to preserve only hybrid cell, and that hybrid cell is able to produce monoclonal antibody, and the entire process is shown here in this diagram. And once you got suppose a hybrid cell, then it can be propagated by in vitro method. So right hand side it has been shown that hybridoma cells can be cultured and stored in the lab, maybe in liquid nitrogen or in any suitable media, so that it can be used in the future. Let's see the different applications of hybridoma technology. So it can be used for flagging cancer cells, triggering cell mediated membrane destruction. It can also block cell growth. It prevents blood vessel growth, blocking immune system inhibitors, directly attacking cancer cells, and delivering radiation treatment. And at the same time, it is also useful in chemotherapy. So these are the applications that are directly related to the biological function of the cell. Other group I have presented here that include different biological assay. So there are different biological assay where we need monoclonal antibody, and those assays are western blot, immunoprecipitation, immunofluorescence, immunocytochemistry, chromatin precipitation, enzyme link immunosorbent assay, flow cytometry, and antibody microarray. So here under applications, what I have done, I have categorized these two components. One is directly related to cell and another one is bioassay mediated application of these monoclonal antibodies. So this is all about this technology. Hope the content is very much clear to you. Thank you very much.